Gosh, I'm trying to think what this winter will be like, and I can't figure it out, guys. That is my mind state right now, because I'm trying so hard to figure out the precision that you need to forecast in long-range forecasting. A lot of people think long-range forecasting is like some voodoo practice, you know, like it's too generalistic to be an accurate science or whatever. A lot of people think that long-range forecasting is like the Farmer's Almanac has depicted it to be, which is basically like, you know, you get a map full of colors and you don't see what they put into it because they don't have a why. They don't tell you what they do, which makes me think they don't have a reason, because if they did, they'd share it with you. For that reason, long-range forecasting is really not just a lost art, it's a secret art that's never been discovered, which is why I'm here for you guys to expound on my gift of long-range forecasting to you all. So we're going to do a couple of reviews today. Looking at the Jamstack model first, because it's a classic, it's accurate. More so classic than accurate, because it's not always accurate. That was kind of misguided information. Let's take a look at our air temperatures for November, December, and January. So again, showing that tongue of cold going from Alaska to the east, it just doesn't look right. And I go with what I said before. Let's take a look at our precip for the fall into winter. And again, dry and dry for the northwest and southeast. Not looking good. Let's take a look at our water temperatures. Again, would you call this a La Nina? I mean, it's hard to say. I wouldn't, but you do have that cooler water in the western equatorial Pacific. So yeah, it's a La Nina by technical terms, because La Nina is when the waters are cooler than normal in the equatorial Pacific. So in all technicality, this is technically a La Nina. We have a warm Atlantic Ocean, a warm Pacific Ocean. This is very interesting because on this model run, this is taking the La Nina, or I should say the cooler waters further north. See what happens in December and through February. It's doing the same, but there's a little bit of warm creeping in. But we still got that indistinct signal. I don't like it, because it's just too messy. For me, at this point of long-range forecasting, I look for organized signals that you can clearly see what it's going, the cause, which is the La Nina in this case, which will affect into something, and with no clarity of if it's a La Nina, you don't know the exact clarity of the cause. Okay, cause and effect reactions here. So it's hard to say what this equatorial Pacific waters will do directly in terms of its affecting the USA this winter. We're going to have to look towards other factors, therefore, like the NAO, which is more of a short-range 2-week forecast. But then again, thinking of that, that's only a 2-week forecast, so that's not going to settle it either. So what do we look to? Well, going back to what I said originally when I first came up with the plan for this video series that I'm doing on my winter forecasts, is we look for the long-range overall trend. The trend is our friend. And the steady trend, not just up and down, but the overall progression of the trend, whether it be cold or warm. So we're going to look at that, and we're going to look at Weatherbell's models, because you know what the trend is. I'm sure most of you who are subscribers have followed these updates, and you know the trend is colder for the northern half of the USA. If not, you do now. That's my forecast hint. Again, not a forecast, because forecasts involve numeric values of temperatures and etc. and precip. I want to take a look at the CFSV2 seasonal, because it's just reinforcing the idea that this winter will be cold, especially from the north. We have another run this morning at 12 a.m. that's reinforcing the whole idea. Taking a look at December's warm, just for this run, it's a stray. You don't have to take it as black and white. We have January is cold. And again, these are daily runs, but they're also looking to confirm my idea that this winter will be cold. No, you're looking for the daily runs as well, not just the long range trend, because the daily runs are important as well. They're just for different purposes. Let's take a look at the Euro Weeklies, which came out yesterday. Winter, 45-day snowfall from yesterday. So this is our latest run. And again, this is looking continually healthy. We have a lot of snow, not only in the Rockies, because mountains typically get a lot of snow. You're not too enthralled that mountains are getting snow, because that's typical. What is a little bit atypical to a certain degree, because the northern plains right here, as you see, that have a lot of snowfall, they tend to get snow this time of year as opposed to December and January. It's too cold for them to snow. What do you mean? I mean that there can be a certain level of cold where it gets too dry to even have precip of any kind, including snow. Therefore, in the heart of the winter, in months of January and December, it can be too cold to snow, because you're getting, the air is too cold. It creates too much dryness. There's no relative humidity or dew points or water vapor in the air. So the other part is that the cold fronts come so ferociously from the north that they push any hope of a snow system down south, which is why our snow season, for example, mine in Ohio, is generally towards December, January, and the first part of February. But also for the Midwest, that's their snow season. Places like Arkansas and Missouri, Chicago, they're kind of in the mix. They're kind of in between the very cold and the very average for winter. But this model has a lot of lake effect snow here, and a lot of lake effect snow in the snow belts. Places like Oswego, New York, Erie, PA, Buffalo, your typical snow belt area is getting pretty blasted with snow here. And also in the UP of Michigan, a lot of snow. One thing that looks very striking to me on this model is the amount of snow in the northern plains, because we've been having a lot of snow in Canada on previous runs, which is not ideal. The ideal is you want the snow to dive south. You want to start getting the jet stream undercutting those northern systems, and you want the snow to start heading south, which is happening in this model run. We see the Dakotas inundated with 6 to 12 inches of snow, and that looks realistic. Just in my gut, it's not really a fact. I just have a feeling this may very well happen. But again, with the Rocky Mountain snow, that's probably going to happen, because they get snow every year around this time. So those are two things that are sticking out quite strikingly to me, is the northern plains snow systems. I mean, you have the whole northern half of Minnesota with 6 to 12 plus inches. You have Wisconsin, northern parts, 12 to 18 inches. Western part of the UP of Michigan, you have 18 inches. It's just inundated. You have the Great Lakes with snow, snow belt of Lake Erie, snow belt of Lake Ontario. You even have a potential nor'easter in the interior New England areas like Maine.